All right, we'll get started now. Hi, everyone. My name is Eric with BobCAD-CAM. I'm the demo tech here at BobCAD. So I do demonstrations of the software program for potential customers. And I also do trainings, things like this, webinars. I also do online training where you could book an hour or a 2-hour session with us, and we can go through any part files that you have to program. And I also do part of technical support as well. If there's any questions that you guys have, and you can call us at the phone number or email us at the email address we have in the comment section here. And we're open Monday through Friday, 8 a.m. to 5 p.m. Eastern Time, and more than happy to help you with any questions that you have moving forward in the software program there. And today's live event, you can see I have you can see in the live event today, I have the main page, the news page that we have on our website. Just to sort of show you, we come out with a news page like this for every webinar and for other tips and tricks for the software program of BobCAD. You can see it's under BobCAD.com, and it's under this button at the top, right here in the middle, news. And there's different articles that we write. Matt does a great job of writing these articles of different CAD and CAM tips and tricks for the software program. Up at the top here, we have mastering thread milling, precision meets versatility. And so it goes on to tell you a lot of tips and tricks for the thread milling that we're going to be going over today. But if you wanted to go back to this and read about thread milling as well, it talks about creating lead-ins and lead-outs. It talks about different thread milling types on the inside or the outside, like pipe threads that we'll go over first, like this here. Side roughing routine, so you have multiple passes, options like that, machine compensation, settings that you can set, different tools that you can use. So it's a great article to read back on after the live event is done, and you can learn more about the thread milling there. So I'm going to minimize this page, and we'll get started here. I'm in BobCAD V37, and I'm going to create a basic file for you guys to follow along with in terms of CAD, and then get into the thread milling here. Sorry, let me scoot my chair in, and I'm going to type in, I'm going to start by going to the top here, going to create 3D, and going to create 2D, and going to rectangle. I'm going to create, let's go 4 by 4, so 4 inches by 4 inches, and I'm going to drop this rectangle down in Z to start with. So you can see the base point over here on the left-hand side. I'm going to type in -2 inches. And then we'll click OK. And then if I revert back to the page here for the news article, this is kind of the model I'm going for here. So my block down at the bottom here, 2 inches going down. And then from up at the top here, we've got an ID and an OD. So the inner diameter under create 2D, make sure you guys can see my screen here. Okay, so create 2D under arc. I'm going to type in my inner diameter. Let's go with 1/8 of an inch. Well, let's see, what is my OD? I'm going to go 1/2 inch. So let's go 1/4 inch for the ID, just to make things easy. And click OK. And I'll go with 1/2 inch diameter for the OD. So all I did was type in a 1/4 inch diameter and then a 1/2 inch diameter. Click OK for each one of those. And then I'm going to go to create 3D. I'm going to go to extrude boss, and I'm going to extrude that down to the square. So I'm going to click on both of those circles. You can see in the positive direction, that's not the direction I want to go. So I'm going to type in 0 for that. And then for the other direction, I'm going to go down 2 inches down to the square and click OK. And then I'm going to extrude the square down from there. So under extrude boss, I'm just going to stay in that function. Dimitri said audio is going in and out. Let me try to adjust this, maybe unplug and plug it back in. Make sure you guys are following along. Okay, how about that? Let me know, Dimitri, if you guys can hear me better. And so all I've done is create a 1/4 inch circle and a 1/2 inch circle for the ID and the OD, and did an extrude boss down to the square here. The square is 4 inches by 4 inches, and it's down in Z by 2 inches here. And I'm just looking at it on an angle here by clicking on my scroll wheel and moving my mouse around to see it on an angle. I can always change the different views here at the top. So I've got my top view, and I'm going to go into one of these isometric views here. And then under my extrude boss, I'm just going to select the square and extrude it down 2 inches as well. And we're just going to do a like a pipe thread, threading on the OD, on the outer diameter of the boss that I have here. Let me also turn up the audio in the software here. Let me know if you guys can hear me better there, or if you still need help with the audio there. But now we've got the solid model, and we can go through the programming side of it in milling. So I'm going to go to the top and go to CAM, and I'm going to start a new job. It'll be under milling, and I'm just going to use the BC3X mill. That is our BobCAD 3-axis milling machine. And for the G-code output, the formatting is going to be a Fanuc-based output. Then I go down to the bottom and I click Stock Wizard. I can define my workpiece, so this is my workpiece here. And then my next page, I could also use that as my stock, I guess, because I don't want to start with rectangular stock and rough all this out first. I'm just going to go to, instead of rectangle for my stock, I can move over to cylinder, move over to wireframe, where I can extrude out a wireframe for my stock. I'm just going to go here to solid, the fourth one over, click on the solid model, and click on calculate stock. And then my last page here is my machine setup page. Machine setup 1 is our G54 location. So if I'm touching the tools off at the center of the hole here, of the ID, I can leave it alone. Say, for example, if I want to touch off at the bottom left corner of the model over here, where my cursor is, I could click on origin over on the left-hand side here, and I can click on that point, and that would be my new G54 work offset location. I'm just going to go back to the top here, and I could also type in the coordinates here in CAD, depending on where I want that work offset to be. So in our G code, G54, X0, Y0, Z0 would be at that position there. So when we output the G code and we do our thread milling, it's going to theoretically move over here, maybe a 1/2 inch with the tool, then come down in Z and then move in X and Y with X, Y, Z0 at this reference point. And so now I'm going to scroll down and click OK on the left-hand side here. And I'm going to right-click on Machine Setup 1 and go to Mill Thread. It's right below Mill 2-axis, 3-axis, 4-axis rotary, and multi-axis. I go here to Mill Thread because I'm going to be threading just on the outside. I don't have to be, drill a hole first and then do my threading operation. I'm going to go right to Thread for the OD here, and then select Geometry. Now here's the thing with mill threading, I'm just selecting a surface edge like this, or the wireframe that I had of the OD. I don't have to click on the surface or any 3D model. I just click on the surface edge or the wireframe that I have there. So it's not necessary to have a 3D model that we created, but it's good to see in simulation, make sure everything's cut to size, and it's useful that way in terms of CAD modeling. But if you want to just get the job done for threading, you can just select a 2D shape of the outer diameter there. So I select the surface edge, and then I click OK for my geometry. We have our total depth that we're going down to. Just to be basic here, we're just going to click 1 inch for our total depth. It picks up our diameter based on the geometry I selected. It's not a through hole, technically. I mean, we're not drilling and threading through, so I'll uncheck that box. And then we go to the next page. This would be for different holes. If I have multiple holes in here, I can select the different holes and set the retract amount between each hole. And we can get into that later if we want to get into drilling as well for threading. Go to our next page. We have mill thread over on the left-hand side. And if it was on the ID like you see here for the diagram, you could do a center drill, a drill, chamfer drill, or milling for a larger hole, chamfer mill, reaming and boring operations. For even larger holes, you could pocket out certain areas. Profile rough and finish on the outside of the OD before you do the mill thread. But we're just doing a mill thread operation here on the left-hand side. And go to our next page. And if we're cutting many holes out of this operation, we can set the sorting order. So optimized would be setting the fastest way to cut each hole, picking order manually for each hole, setting it in an X or a Y direction. It's sort of like the new pick order option. You can click on the pick button, and then I can click with my mouse, and I'm just sort of moving a stencil around, and the first hole that I intersect with that line there, or that spline, you could say, it'll pick that one. And then as I'm following along the block, picking the order would be how I drug this spline around with my cursor. Then I think I click a second time, and then click OK. There we go. And then our next page, we've got our work offset number 1. Putting in arc moves. If we have an older machine and the older machine doesn't take arc moves as well, you can output the G-code as line moves, as tiny line segments around arcs. So that's what those two options are for posting. Our next page, we're setting up the tool. So this is our single point thread. We can type in the thread angle here. We can also go to the tool crib, and we have all of these tools in here. And I'll go with, let's see, we have quarter 20. Yeah, quarter 20 type of tool here, single degrees, 60 degrees single point thread. So quarter inch and a quarter inch OD for the quarter inch diameter for the tool, and cutting 20 threads per inch, I believe is that, those numbers there. So from the tool library, I'm going to click on the tool. I can move it into my tool crib with this arrow here, or what I tend to do, because this is sort of the newer formatting, the newer interface with our tool crib and our tool library, sometimes I forget to click on that arrow still, so I tend to drag and drop it into the tool crib to make sure that it's in there. And then I click OK. Then down here we can type in our spindle RPM and our cutting feed rate. Our next page, we have starting from the top down or starting from the bottom, working our way up. And the thread type, if it's inside or outside. I'm going to select outside here. We also have side roughing if we want to do additional passes and how far they're going to be spaced out. And here's our system compensation, as I was mentioning there in our article that we have. So system comp will compensate the tool in the tool path and just offset it for the radius of the tool. In machine comp, left it will output G41, and machine comp right will output G42. So that way it will compensate at the machine when you type in the controller, the diameter of the tool, and you can output for tool wear and things like that for your machine comp left or right, G41 and G42. Then we go to our next page. We can type in the thread diameter, and we can type in the thread height, the thread pitch. I like clicking on each of these numbers to make sure these numbers are, looking at the diagram to see what I'm actually looking for. Threads per revolution. If it's a tapered wall, we can type in the tapered angle for a tapered thread. And I normally don't change the numbers here, thread height and thread pitch. I normally click on this checkbox up at the top, thread library, and then select the thread type that I'm using. And I'm going to go with the 1/4 inch 20 there and click OK. I might have to do 1/2 inch because it's 1/2 inch OD. We'll test that out. Taper from top or taper from bottom. It's not a tapered angle, so I'm just going to leave that alone. And then down at the bottom, right hand or left hand for the tapering option there. I'm going to go with right hand. And then our next page, our lead in and our lead out options. So circular, we'll kind of go in like a 2D fashion here in X and Y and do a circular lead in. Helical, you can see just sort of a small difference there with a tapering for the lead in and lead out. So it's gonna go along that helical approach as it would do the threading. So I would select right angle, or I can type in the angle direction it's moving around into the lead in and the length of the lead in before it goes around. I normally keep it just at right angle, and then you can change the length of it, change the radius of the arc that it's leading into, and the sweep angle if you're just doing a 90-degree corner like that. And then lead out, you can use the same as the lead out, or you can change it to circular maybe, circular lead out to use that. I'm going to stick with the same as the lead in. Then our last page here is MDI. MDI is a newer page. I think it started in 35 or 36 into 37 here. It stands for manual data input. It's under every milling and lathe operation now. Used to be in mill turn, but now it's in every single one of them. It's for you to be able to manually enter any G or M codes manually. And so you can do it before or after a tool change, or after the operation is over here. Just to show you, if I'm at the MDI page, I'm going to highlight after operation. You could add a dwell time, a feed move, a different work offset command. What I normally do is highlight raw text, and then I can go down to the bottom here, click on add command. And then I can type in any raw text here. So if I type in test comment, it would just print the text like this here. If I click on comment here, it will add parentheses for me before and after the text I added. So just sort of a side note, we can look at it in the G code. So I'll hit compute. We'll take a look at the toolpath. Yep. I think just as I expected, I'm at a 1/4 inch, which is too small for the 1/2 inch outer diameter. So I want to go back into the feature and edit that. I would right click on the feature here in the CAM tree, go to edit. I would go to parameters. So it's the second page down below the tool page. And I change my thread type to 1/2 inch. 1/2 inch 13. And then click compute. Now the tool path is looking better. I know that the tool path normally has to be seen on the outside for the compensation, for threading, things like that. The blue here is the lead in and lead out, so it's going to move here and then move around before it goes into the approach of the thread milling operation. Neat thing here before I go into simulation for all of my milling operations or for all of my turning operations, I can right-click on an operation below any feature here. I can right-click and go to backplot, the fifth option down. So you don't have to go into simulation every time to view any operations individually. You can go to the backplot and you can step through here, see it plunge down, move over, do the arc, and then it does all the threading operations there. You can see it down at the bottom here. See if the tool is offset enough. Looks like it's right on there. And then it does the lead in or the lead out and the linear lead out move as well. Is the tool long enough? Yeah, tool's long enough. So I'll close out of the back plot. And what I would normally do is I would save the file here, and save it as a BobCAD file .bbcd, and name it web. And I'm going to go to the top, go to simulation. Based on, what was that, 9.5 inches per minute feed rate, you can see up at the top, this number here, 2 minutes and 46 seconds is the estimated cycle time for this thread milling operation. Then I can hit run at the top. If your simulation is any different than mine, let me know. There's a few settings that you can change in here to make sure everything looks correct. For example, the time right here, if you don't see that, you'll see up at the top left here, time mode. You can drop that down. There's a couple other options. There's NC mode. It'll tell you how many lines of code it will take to do this operation. And length mode will tell you how many inches of travel to do your milling operations with. I tend to keep it at time mode to see the estimated cycle time based on my feed rates. And it's also a much smoother simulation than the NC mode, because it reads the G. It doesn't read the G code line by line, but it simulates the G code as if it's just going to do one quick thread milling there. Now you can see the red here with the stock and with the tool. That's what I was thinking. It might have been running into it a little bit. So based on the tool geometry, I think it's not able to create that thread height. So it's a great simulation to show us that there is some gouging actually with the non-cutting part of the tool and the stock there. So again, I close out a simulation and edit the feature. So I right-click on the feature, go to edit, go to parameters, no, go to patterns, the page just above it, and no, where am I at? Oh, here it is. Yeah, parameters, I was right. So I'm going to uncheck thread library, and I'm going to change the thread height. So the thread height isn't possible for this, so I'm just going to go 20. I'll leave everything else alone there and hit compute, and that should compensate over far enough, depending on the tool. Now we have great ways to create tools. There we go. Now that red is just showing cutting, not gouging. We have great ways to define the specific tools that you have at the machine. You can define the profile of the tool in 2D as CAD geometry, and then go to your tool library and assign tool geometry to be able to create any type of tool for threading or form cutters, things like that. You're also able to import tools from the tooling manufacturer. If you go to their website, normally you can save it from the machining cloud. It saves as a zip file, and when simulation is over, and if everything's good with what you want there, you can close out of simulation And you can post a G-code up at the top. Click post. You can see the G-code down at the bottom right corner here, right there. And then you can scroll down and you're able to see, yeah. So here's the test comment in parentheses that I have for my MDI page. So that's how you would create the thread. Yeah, Frank, thank you for letting me know. Different tool that I need to use for that thread, but it's a good simulation to be able to see how to create the outside thread milling there. And we can get into doing drilling and threading on the inside for another part file. Let me know if you guys have any other comments, questions, concerns. Like you said, Frank, if you needed to change the tool, you can go into the thread library. I think, like you're saying, probably need to use even a larger tool for the 1/2" OD there. Or actually, no, different thread type. We're at UNC. So if we went to like pipe thread, NPT, I think that's what you're saying is use a different tool, like something like this here. But yeah, whatever type of tool you're using there, yeah, definitely not it. But whatever type of tool you're using there, you can go in to the oh, I guess you also have to go to the tool page and select that tool as well. But yeah, so you have to select the tool in the tool page, and also under parameters, select the thread type under the thread type and thread size there. But yeah. Anyways, please let me know if you guys have any questions, comments, concerns in here, and yeah, and if you guys have any questions, let me know in the comments section. And if not, I'm going to go to threading for the inside for drilling, and then threading on the inside with a similar tool like this. I'll go to my next file here. I'll show you drilling as well in here. For a 3D model like this, you can see different hole sizes. And I'm just going to create a new job again for the 3D model here. I'm going to go to CAM, go to New Job, and we have our machine for VC3X mill, and go to Stock Wizard. Select my workpiece as my 3D model here. And then I'm going to stick with the stock definition as rectangular, so we could get into 3-axis milling for the mold here. I'm not going to get into that today. That'll be for another webinar for later on. But I'm just going to leave it as rectangle here, and I can type in the dimensions here, my length, width, and height. And then you can also see the offsets. So say, for example, if this was 10 by 10, and I type in the dimensions here, 10 still stays at the center of my 3D model, and also like for the Z, I think the Z goes down. It doesn't go up and down. So I'm going to hit calculate stock again, so it forms to the 3D model that I have. That's where these offset numbers can come into play. So offset positive in X. Let's say I do a 1/2", it'll offset in the positive X direction, but not in the negative X direction until I type in the offset here for offset negative. That can be very useful for the offset positive in Z. So if I needed to do a facing operation first, say an extra 100 thou on top, I can just type in 0.1 right here, and it would give me an extra 100 thou on top of the stock there for a facing operation. But I'll zero that out. And we'll go to our last page here, which is for our machine setup. It starts by default at the CAD origin location. So that's why I tend to have my part files or my drawings where the bottom left corner is right here at the CAD origin location, so I don't have to fool around with the machine setup at all. That's where I'm touching off my tools. If I'm touching off my tools here at the upper corner of the stock over here, again, I would just highlight origin and click on this corner, and that would be my new G54 location in the G code from there. I'm going to go back to this corner here and scroll down to the bottom and click OK. And here's our milling job. We have our stock that I can change at any time. My machine setup I can change at any time by right-clicking and editing. And when I right-click on machine setup 1, I can go to, let's go to mill drill hole first. So that's about 5 or 6 down here. Mill drill hole. Select my geometry, and I'm selecting holes of the same hole size for this operation. And then you can see the total depth I can type in, if it's a through hole or not. And then our next page for drilling is we can get into the group retracts for drilling before we get into threading on the inside. So here's my group of holes. You can see the diagram here of the 4 holes around the part. If I want to do a group retracts, and I can explain what that is, first I need to highlight the group down here and then click on break hole group over on the right here. Now it breaks it up into individual holes that are highlighted around the part for each one. Let's say I want to group the top 2 together. So I highlight one, I hold Control to add more highlighted holes here, and then click regroup holes. And I'll do the same thing for number 3 and number 4 here, and then click regroup holes. So now I've got 2 different groups. I've got group here for the 2 bottom ones and group here for the top 2. Those are 2 different groups of holes now, and I can go to group retracts, and I can set a retract plane. Let's say a retract plane of 5 inches, and I'll click OK. So when I do my drilling operation, once I hit compute for this, you can see when it backplots, starts up at 5 inches, I believe. Yeah, starts up at Z5, comes down with the drilling operation, just goes to the rapid plane and rapids across the 100 thou to the next hole in the same group. So this can be helpful if there was something in between these 2 hole groups. Say there was a boss or there was some kind of clamp that I need to retract above. You don't have to retract the 5 inches for each hole. You can group all of your holes on this side and go across 100 thou and wrap it across each time. And then once you go from group to group, you can set a retract plane of 5 inches like this, so you can save time with the retracts there. So that's what the group retracts is for in the drilling. I tend to go over that a lot because people tend to overlook that. And so if I break all of the holes into different groups now, theoretically, you've got all 4 separate again, and I hit compute, you would see that all of them are retracting 5 inches. So that would take some time to retract every single time there. That's what the group retracts would save you time with. So we'll close out of the backplot, and I'm going to delete that feature. I'm just going to highlight the feature here in the CAM tree and hit delete on my keyboard. And we do have ways of saving time with drilling here as well with a 3D model by right-clicking on Machine Setup 1, and we have this whole recognition page. This is the 3rd option down from the top. Select that, select my model, and hit OK. And it will give me sort of a window here with checkboxes of which holes I want to drill. If I highlight each one, it'll show me, okay, this is the 1/2 inch over here, and these are the 1/4 inch ones, and then I click compute. It'll also ask me if I want to do a chamfer on any of the holes, and if they're a blind hole or if they're through holes, I'm just going to leave that unchecked. And there is tapping and counterbore here. There's not threading, so we have to get into threading after drilling here, but if you wanted to do a tapping operations, you can do that here as well, or counterbore. And we'll hit compute. And you can see all of the toolpath is computed for me automatically with different features for the different hole sizes. So that would save you some time. If you're drilling many holes on one side of the part, it only focuses on that side based on our machine setup. And then if you had to do some drilling on the other side, do another machine setup and do your hole recognition, it'll group out all the hole sizes for you and will give you, in this case, a center drill and a drill operation. You can save these settings for your hole recognition page up at the top. If you go to CAM and you go to knowledge base, that's what this knowledge base icon is for here. So you have different settings here, whether you wanted to do a center drill and a drill, whether you wanted to set, if it's a certain chamfer here, there's certain rules you can set up. If the chamfer is less than 625, it'll do a chamfer drill operation by default. If the chamfer is more than or equal to 625, it'll do a chamfer mill operation. If the depth is a certain amount, this rule is if the depth is less than 3 times the diameter, so if it's a shallow depth, it'll do a single depth for drilling. If the depth is deeper, it'll do a pecking operation. So you can set up rules like this depending on the depth of the hole, do a pecking operation, and all of those settings, so it'll calculate all of the drilling operations for you automatically there. So once we've drilled all the holes on this part, I'm going to focus on the 1/2-inch holes, top and bottom here in the middle. I'm going to right-click on Machine Setup 1, and we're going to go to Mill Thread again for an inside hole. Still the same option there. And the same kind of workflow here too. Just selecting my geometry. I'm just going to select the surface edges on the top here of the 2 holes. And click OK. And then I can pick bottom. If I know the depth, I can type in the depth here. If I don't know the depth, I just pick bottom and click on the bottom edge of the solid model to pick up the total depth of 2 inches there. And it's a through hole. So when you're drilling, the through hole option will go an extra 50 thou to clear it, plus an extra amount based on the tool geometry of the tool tip, the angle of the tip there. For threading, I'm not sure. I think it might go an extra 50 thou if we select through hole. Let's see what it does there. I'm gonna click next. Then here's our groups and our group retracts. So again, just 2 holes, so it's not gonna give us too much of a difference there. But if I wanted to separate them out and set a retract plane between the 2, I can do that here with group retracts. If not, it's just going to go with the rapid plane of 200 thou, it looks like here. And then our next page, mill thread. If I wanted to do the center drill and drill here, I could very well highlight center drill, move it over, highlight drill, move it over, and then I can sort the operations with these arrows over here. So I would highlight center drill and move it all the way up. If I don't want to do the center drill and drill, I've already done them in the hole recognition. So I'm going to highlight center drill and delete it, highlight drill and delete it with this red X icon, and just stick with the mill threading. Go to my next page. We have our sorting order. It's going to go the optimized way here. Only 2 holes, not going to make too much of a difference there. Our arc output for the G code. I'm just going to leave that to what it is. And then our tool page. I'm going to go to the tool crib and sort. I tend to sort by diameter and scroll down and look at the different tool pages. We also have the thread mill option up at the top left. This type of tool. Let's select that type of tool here, sort by diameter. And I think I'd be selecting 1/2 inch. We'll do 1/2 inch 20. So you can see sort of a multi-point thread tool here rather than just a single point thread under single point thread there. So I go to thread mill, sort by diameter. I'll do the 1/4 inch 20 and I'll drag it into the tool crib and click OK. Hoping that's the right tool. For this one, it's not the pipe threading, so at least we can go with the universal type of tools there. We go to here. I'm going to start from the top down. I'm going to cut on the inside. We could do side roughing if we want to do multiple passes and work our way to the edge that we're cutting there. Then we have our system comp and machine comp. And again, same kind of workflow as the outside cut that we did on the OD. I'm just going to check the box thread library. It's giving me the 1/4 inch. I think I did 1/4 inch 12, 1/4 inch 20, but let me do 1/4 inch 13 then, just to make things easy for me. I'm sorry, 1/2 inch 13 there. Let's do that. So I did 1/2 inch 13 for the thread under the tool page, my spindle RPM and cutting feed rate. Starting from the top down, cutting inside, 1/2 inch 13 for my thread type, and it fills in all this information for me automatically. I can set threads per revolution. Just do one each pass there. And if there was a taper, I can start from the top down or from the bottom up for the tapering. And then the direction, right hand or left hand for the thread. Then if it's a helical move or circular, and then helical or circular for the lead in and lead out, and then our manual data input page. I'm going to click OK or hit compute. It looks like the lead in might be too large, so I'll right click on the operation and backplot, check that out. It is starting here, working its way out to the stock, and then working its way in. So let's make sure the thread is long, the tool is long enough. It doesn't look like it is. And let's make sure that the lead in and lead out is small enough as well. I'm going to go to the tool page first. I'm just going to go to this drop down here and click on Modify Tool and type in the overall length. Let's see, protrusion length has to be more than 1 1/8. So let's do 2 1/2. And click OK. And then go down to the leads page and lead from center. The radius can't be the same as the 1/2 inch diameter. So let's go with 100 thou for the radius. And we'll hit compute. That's looking a lot better. I'm going to look at it from the top down and see. Well, looks like the lead-in does go past the green tool path here. So maybe I want to do it even smaller for the lead-in and lead-out. Go 50 thou. That looks better. And I'm not going to save the part file, but at this point I would save the BobCAD part file. So I can reopen this BobCAD file in BobCAD at any time, and got my geometry, and I've got the drilling and threading operations here. But I'm going to go into my simulation. And we've got our center drill operations first. I'm going to slow down the run speed of simulation, then hit run. Speed it up a little bit here. And based on the feed rate, it says it's going to take about 18 minutes for the drilling operations and threading here. So we would want to change the cutting feed rate, I would say, after we've done the drilling there for the 1/2 inch holes, for the 1/4 inch holes, and then for the threading here. And then once everything looks good, we can close out of simulation. When it comes to the feed rate, I can type in the numbers manually here on the tool page, or I can change it also based on the system feeds and speeds here. So again, I could uncheck this, use system feeds and speeds, type it in manually here, or I can check this box, use system feeds and speeds, and that calculates these numbers based on the material type I'm using for the stock. And that is found under stock in the CAM tree. If I drop this down, right click on what it says carbon steel here, and go to edit, it'll open my material library. So these are all different material types that we have built into the system. And whether I'm machining from carbon steel, aluminum, different types of plastic, I have feeds and speeds for each material type. I can double click on it, and I can also select the tool type I'm using as well, whether it's carbide, insert, or high-speed steel, and type in my surface feet per minute for tapping, chip load per flute. So I can set those numbers in here. So when I change it from carbon steel to cast aluminum, go back to the tool page here, spindle RPMs at 10,000, the cutting feed rate is at 57.5 inches per minute. So a lot faster into aluminum than steel here, it looks like. And when I go to the cycle time, it's cut it down from 17 minutes to 1 minute and 47 seconds. So those are some conservative numbers for the material types usually, in terms of carbon steel, aluminum, different types of plastic in there. We always recommend that you contact your tooling manufacturer and make sure those numbers are dialed in for your specific tools. If you ever need to change them, you can just double click on the material library, double click on a material type, and change the numbers in here, and click OK to save the numbers in the material library there. And from here, we can, again, save the BobCAD part file. So I'd go to save it as the file extension .bbcd. So you have your part file here. And you can open this part file in BobCAD with all of the drilling and threading operations that we went over in the file. And then when I go to post, it'll generate the G code over on the right-hand side here. I would right-click here in this window and go to Save As, and I can save that G code file as file extension .nc, or you can change it in here, change the file extension if you need to, but then you can save it onto a flash drive, load it into the controller from there of your machine. If you have an older machine, you can also right-click in this posting window, and we have our NC editor. This will load the G code in a new window where you can modify the G code if you want to here. You can see the nodes here are in green, XYZ moves are different colors. And in this window, I can go to the Tools tab over all the way on the right and click on Start DNC Transfer. So if you are using an RS-232 cable, you can set the port number, the baud rate, and all of those settings to send and receive from the CNC machine in this program as well. I'll close out of that window. David, why in simulation is the tool and holder red in the operation? Let's check this simulation here, see if it's showing red. So yeah, okay, so even the drilling is showing red, and it's not hitting any non-cutting part of the tool or the tool holder here, but it is showing in red. Good question. You'll see that a lot in your simulation here getting started, I would say, and not knowing what that is. For one reason is if you just have the 3-axis milling, it doesn't have the simulation standard, so you won't be able to see this here. You won't be able to see the machine. And so I'll show you what that looks like. If you drop this down from workpiece stock to machine, it'll show you the machine, and it'll show you actually that the stock here is sitting inside of the table. Now the reason for that is because our work offset is right over here, and it starts at the top of the table. To change that, we can close out a simulation. We can right-click on Machine Setup 1 and edit. Down at the very bottom, where I can change my work offset number from 1 being G54 to 55 or a different work offset, Right below that, we have these X, Y, and Z values, work offset X, Y, and Z. This is our reference point from the work offset at the top of the table in the machine position to raise that up along with the stock in simulation. As a side note, if I change these numbers, it doesn't change anything in the G code. It only changes the coordinate system in our simulation page. So if I raise this up 2 inches in Z and click OK, it's going to raise this position in simulation 2 inches up out of the table. So this position here, the bottom of the stock, will be raised up 2 inches. And I'll take a look at that in simulation here. And now you can see in my simulation that the stock is just above the table there, sitting right on top of the table. So that would be the reason for the red in simulation before, because the drill was drilling into the table there. You might not be able to see it in your simulation with the machine, because the machine components here are only found in the Machine Simulation Pro. That is unlocked on your license if you have 4-axis milling or above, or you could pay the difference to be able to see the machine in here and also model the components to your machine. So the spindle, the table here, and everything else in our simulation, these are all STL files that you can model in BobCAD and be able to import into the simulation in the Machine Simulation Pro package to be able to view if there's any collisions there at the table and the geometry that you input and things like that. Now it's going an extra 50,000, probably even an extra 100,000. So that's what we're getting red with the tool and the table here at the end of the drilling operation, once it picks all the way down. But yeah, good question, David. That's why it was red throughout the whole simulation. There wasn't any gouging necessarily. It's just based on the orientation of the stock on top of the table of the machine there. So that's what that would be for. It's plunging through the stock an extra amount to clear through the stock. If I wanted to, I could raise the stock up a little bit more so that you don't have that red at the end of that drilling operation there. But yes, again, you can unlock Machine Simulation Pro. It's usually a little bit of a price to upgrade to that. I'm not sure what the pricing would be, because that's more of a sales question there. You can call us and we can tell you what the difference would be to add that onto your license, so that you can see the components to the machine like this here, to be able to save as STL files, your table and everything else for your specific machine, and see that in simulation here. But to also get into STL files, we could get into the CAD side of things in terms of the thread. Now, if you're familiar with the CAD package in BobCAD, creating threads is very, very difficult. So we do have an easier way to create threads in CAD than, creating the geometry, creating a sweep like this, a helical sweep, and extrude cutting to cut away for a thread. Usually doesn't work out for us with the CAD side of it. But once we create the tool path for mill thread like this, we go to Start Simulation. I can see the stock is inside of the table for this one. So I close out of simulation. I right-click on Machine Setup 1, Edit. I'm going to change it to 4 inches. At the bottom here, this work offset XYZ. Raise it up 4 inches in Z so that the bottom of the stock here raises up to the top of the table. Start my simulation. And then once the threading operation is done, I'm going to run through it. Mess around with the numbers here, so let me change the tools fine. I'm going to change it back to UNC. I know it's not the correct one specifically, but I just want to create a thread on this here and be able to simulate and get some kind of thread on the stock. So once I have the thread that I want in simulation here, after I change the thread height, I'm just going to change the thread height to 20 thou, as I had before, and go into simulation. I'm going to run through it. And for example, if this is the thread that I wanted on this part, and I wanted to save it as an STL file, we have that option in the simulation here. Down at the bottom right here, you can see this yellow tab right here next to me, the yellow tab, and it's labeled Analysis. So I click on that yellow tab, Analysis. I click on the, no, sorry, it's the next one over. It's the blue tab, the left one, the blue tab to the left of Analysis here. It's called CutSim. This CutSim tab is where you can click on this save icon of this floppy disk. It's labeled Save Stock. You can save the stock after the milling operations as an STL file here. So in my downloads, I'm going to name it stock123. Save it. I'm going to close out of simulation. I'm going to go to File, Open, and I'm going to go to my downloads and open that stock123 file. And that here, there's a newer option. You can import it in inches or in millimeters. So I select inch, click OK, and then I've got the stock file after the threading operation. If I wanted to change the color, I can go to my select mode, click on the stock or the 3D model here, right click anywhere here in the CAD workspace and modify the color. Change it to a darker gray color there so I can actually see it. So that is the way you can save, that's the way you can create the CAD geometry of your thread to save as an STL file. You can 3D print this now if you wanted to. Not a whole lot more you can do with STL files, but you can, in other CAD software programs, I tend to use, for 3D printers, just this sort of, it's off topic, but if you save an STL file in Thingiverse or any other open source website, thingiverse.com, or any other software program, GrabCAD, you can save an STL file, but you'll notice you can't make any adjustments to an STL file. I found a free software program called FreeCAD. You can download and you can actually import an STL file and convert it to a step file to make more adjustments after the fact there. So kind of an off-topic thing about STL files. If you wanted to create a thread, change it to a step file, then change anything else about the part file, you could do that. So we're closing in on an hour of our live event today. I'm getting to the end of the information here for mill threading. If you guys have any questions, comments, concerns overall about what we've gone over today with mill threading, please let me know in the comment section. More than happy to answer anything else that you guys have there. And if not, we will see you guys in the next webinar here. It's every other Wednesday. So today's the 23rd. So not this Wednesday coming up, but next Wednesday, November 6th, we will have our next webinar. And the topic is to be determined. We tend to email you guys a survey, ask you a few different topics, which one would be the one you'd like to see. So please let us know in the survey there what you would like to see in the next webinar, November 6th. We try to tailor it to exactly what you guys want to see in the webinars here, so we get more people viewing the live events. David, not related to threading, but now with 37, when you select multiple items, right click, yeah, I already know where you're going with this here. When you select multiple items, so not just the solid model, but multiple solid models or multiple pieces of geometry, right click. You don't get the option to modify attributes. Only way, I'm actually curious what your only way is here. Only way is to use the on-screen pop-up icon, then select, so the contextual toolbar will allow you to do that once it pops up. And it will allow you to modify the color like we saw here, modify the gray color or modify it to a different layer. Yes, we have noticed that, David. Thank you for letting me know. But yeah, that is already reported to our development department, and that's worked on already for the next update for you guys. So it's a good thing to point out, though. I've noticed that you can select one item like this. You go to select mode, you click on a solid model, right click, and there's your modify attributes. let's test it out here. I've got multiple solids here. Select both of them. Hey, where's my modify attributes? But yes, that is reported to development department. I think we have an update. If it's not already come out, check on BobCAD-support.com, and under downloads, we may have an update for that already. If not, it's going to be in the next update, the next software build. But yeah, thank you, David, for letting me know about that. That's a good one that you caught there before our next update. But yes, like you said, in the contextual toolbar, once you click on something, you have the contextual toolbar to be able to modify multiple things to a different layer. That's going to be the most important thing. If you want to move wireframe to a different layer or something like that, you'll have to use the contextual toolbar for the time being. But yes, thank you, David, for that point, and thank you, everyone, for viewing the webinar today. Hope to see you in the next one. It's going to be November 6th, same time, 1 o'clock Eastern time there. And thank you again for viewing the live event today. Hope to see you next time. See ya.